All right, math fans, let's take a look at rational expressions. So, first thing, what is a rational expression? So, rational expression for us, let's do this in black. So, when we think of a rational expression, we're thinking of two polynomials um, as a fraction with the denominator not equal to zero. So, with the denominator not equal to zero. So that's our definition of a rational expression, right? So we have two polynomials as a fraction. So rational expression. So two polynomials as a fraction with the denominator not equal to zero, right? So basically what we're looking at is that we can have some undefined values when the denominator is zero. So when we look at restrictions, right? So that's short for restrictions on the domain, right? Values that were not allowed, restrictions, non-permissible values, things like that are things that, or we could say where the function is undefined for that. That's places where we're going to have division by zero. So they occur when division by zero happens, right? And we don't like division by zero. It leads to a whole bunch of nasty consequences that we're going to investigate later. But your middle school math teacher says we don't divide by zero, and we don't, and we're going to see why just a little bit later in the unit. Just take it on faith that right now we're not going to divide by zero. So for example one, let's see how we get these undefined values right now first, right? Because we need to know where we can and can't work on our values of x, right? Since we can choose x anywhere, we need to know where we can't choose x to start. So if I have 2 over x, well then here x can't equal 0, right? That's totally something x can't be here. If I have x plus 2 over x minus 3, then I'm just looking on the bottom, and I'm going to check the bottom, right, the denominator, and x minus 3 cannot equal 0. And so I can do algebra across the cannot equal sign, and I'll get x cannot equal 3, right? So x can't equal 3. If I had x equals 3, so try, right? So I'm going to try. This was A, this was B. So let's try it out. I have 3, and this will be x plus 2, and this was x minus 3. That would be 5 over 0, not allowed. But I could have any other x value, and it's totally okay, right? All right, so that's what it just is a quick way to tell us what works, what doesn't work. So if I have 1 over x squared minus 9, well, that's not immediately obvious to us, but what we can do is just say x squared minus 9 cannot equal 0. And you can do this two ways. You can see it as a difference of squares, or you can solve it as a radical, and we'll get x squared cannot equal 9. And since I have a variable here, my answer will result in plus or minus, and I can get x cannot equal plus or minus 3. Totally works. Or I can recognize it as difference of squares. X minus 3, x plus 3 cannot equal 0. So here x cannot equal 3, or x cannot equal negative 3. Right? Either are solutions over here for us too. And then what about 1 over x squared plus 9? Well, if we have x squared plus 9, x squared plus 9 cannot equal 0. Well, for me, what that says then, x squared cannot equal negative 9. Well, that's impossible. So that's, and we know that x squared plus 9, not factorable. So this is okay, right? That we know that x squared is always going to be greater than or equal to 0. So if I have x squared plus 9, then I know that x squared plus 9 is always going to be greater than or equal to 9. So I'm never going to hit 0, right? I'm never going to hit, and I'm not even going to hit any negative numbers. I'll never be able to get below 0 here. It's just not possible, right? Okay, so let's take a look on some more reducing to lowest terms. So one thing with fractions, and one thing we always want to do, and something I noticed on your assessments from time to time, and not just you guys, but other classes I teach as well too, is that uh, making making progress on a problem is a lot easier if you simplify before you begin. Oftentimes, when you get given a problem, it's not in the simplest terms, and doing the operations in non-simplest form creates a lot more work than is necessary. You're carrying through common factors that could be canceled out 7 steps ago, and it just makes it introduces more chances for complication to enter. So one thing that you really want to do, and especially we really highlight that in this unit, is take a look and reduce where we can right away, right? So when we think about it, right, we think about, for instance, if I had 12 over 24, right? Well, I just know that this is actually 2 times 6 over 2 times 12. That goes away, but 6 is also 2 times 3 over 2 times 6. And this is just going to be 3 times 1 over 3 times 2. And this is actually 1/2, right? This is simplest forms. What I've been doing is removing shared factors between the denominator and numerator. And notice how there's no addition and subtraction. We're just removing the shared factors, right? So this is called simplifying. We may hear canceling, right? But the actual process is called simplifying. Right, so oftentimes what simplifying looks like in the general form, if they share a common factor, if I have a times c and b times c, and c is a common factor of two numbers, well then my fraction is actually a over b, right? And b and c cannot be equal to 0, right? So it's just the general rule that if they share factors, that's the actual number I have. So can I do this with rational expressions? So let's look at example 2. Can we do this with rational expressions? Let's try it out. So if I have this, if this is 2, let's go 3x minus 3 over 6x minus 6. Well, I have addition subtraction on here. It doesn't look nice. What I'm going to do is I'm just going to take a GCF where I can, right? And especially if my goal is simplification, right? That's what I want to do here. I want to simplify this, and this is 6, and this is x minus 1. I can see here that I'm going to get the restriction from this step, right? I'm going to get the restriction here, and the non-permissible value is that x minus 1 cannot equal 0, so that means x cannot equal 1. But when I do this, I know that x minus 1 and x minus 1 are the same number. If x was 5, x minus 1 is 4, and 4 over 4 would cancel out. If x was 6, x minus 1 would be 5, and 5 over 5 cancel out. I also know 3 and 6 share a common factor, and so all I'm going to get here is that this is going to be 1/2. So all this is going to be equal to 1 over 2. X cannot equal 1. And that restriction happens before our simplification as well too, right? We get all restrictions before simplification. Let's try another. So if I have x minus 2, and we're going to simplify this again over x squared minus 4, well, we can't do anything on the top. So the top all belongs as one factor, but I can factor the bottom and turn it into multiplication, and I'll get x over x minus 2 over x minus 2 times x plus 2. Here, I'm going to see that my non-permissible values, x cannot equal, right? X cannot equal plus or minus 2 here, right? That I can look at the denominator and say, from here, x can't equal 2, and here, x can't equal negative 2, right? I can take a look at and finish that linearly. And now that I have same factor and same factor, they get a simplify out, and my final result will just be 1 over x. This will just be 1 over x plus 2. Just like that, right? So nice and simple, easy to work with over there. No, and I should state my restriction beside it. X cannot equal plus or minus 2. And here in this case, negative 2 for sure doesn't work, but we still need to ensure that that restriction of positive 2 is maintained even though we simplified it. And the reasons for that will become a lot clearer later on. Let's do one more, and then we'll pause this one here, and I'll finish the part B later for you. Okay, so let's simplify something just with variables by itself. So I'm going to have x squared y plus xy squared. And just So we know what a valid strategy factoring it is. Xy plus y squared. We're good. Here, let's do any simplification we can, or let's just collect common factors. Start on the numerator. Xy is going to be a common factor for us. And we're going to get x plus y as one of our terms on the numerator. And on the denominator, it looks like y is a common factor for us. And we'll get x plus y here. Now, at this point, I know that y cannot equal 0 and x plus y cannot equal 0. So let's just get, since one of our restrictions is in terms of y, let's just get the other one in terms of y. So what I'm going to do is subtract x from both sides on this one, minus x, minus x. So this is case 1, this is case 2. And I'm going to have y cannot equal negative x. So those are my two restrictions. Those are my NPVs right here, right? Non-permissible values. When I'm looking here, x plus y is the same as x plus y. If x was 1, y is 3. That'd be 1 plus 3, that's 4. Then I get 4 over 4, right? And this is all multiplication now. This is x times y times x plus y, right? So I'm not having any addition subtraction. The addition subtraction that's happening with x plus y is happening inside a bracket, so I can treat everything as multiplication. That's y over y. So it all simplifies down into x. And I have my restrictions for x that y cannot equal 0 or negative x, right? So I know I can't have those values over here as well too. Good. That was a quick one. Let's do one more. So let's do one more, and we'll see two polynomials as a fraction. So we're going to get x squared minus x minus 6, and this is going to be all over x squared minus 4. And factoring this is going to be x minus 3, x plus 2. And we're never worried about the non-permissible values from the numerator. And this will be x minus 2, x plus 2 as a difference of squares. Right? The zeros on the numerator we don't care about, because if I had x is equal to 3, well, that'd be 0 over, that'd be negative 5. So this would be negative 0 over 5. Well, that's just equal to 0. I can have 0 pieces of something. That's totally okay. So on the numerator, I don't care about non-permissible values there. Let's just get the non-permissible values here. The NPVs, both cases, I can see right away that x cannot equal plus or minus 2 here, right? I'm not allowed to have that. But I can cancel out the shared factor, right? I can simplify that shared factor of x plus 2, and then I'll just get x minus 3 over x minus 2, and I know that x cannot equal plus or minus 2, right? So I have that as my solution there. Okay. Yeah, let's just finish this. And let's do one more. We have x squared minus 9 over x squared, not x squared, 12 minus 7x plus x squared. Let's factor this. This will be x minus 3, x plus 3, and this will be 4 minus x, 3 minus x. If you're unsure how to factor that, come talk to me. You can do it several ways, but you can use the box method as well too for that one, right? 4 and 3 are going to make 12. I know I'm going to have negative x and negative x on the back there. Now, on this case, though, I don't have a pair of matching factors, right? That this and this are not the same. But what I can do is GCFs of negative 1. So what I'm going to do here is two things first. Let's just get the non-permissible values. The non-permissible values here are going to be x cannot equal 3 and 4, right? That if I had, let's do that the long way. 3 minus x cannot equal 0. Well, then I can add x, and then x cannot equal 3. So that's case 1. And then case 2, we'll get 4 minus x cannot equal 0. So x cannot equal 4 if I add plus x, right? I can do the algebra anyway there. What I'm going to do here, though, is I'm going to do a little bit like, going to be sneaky, right? So I'm going to have x minus 3, x plus 3 up here. What I can do is I can take a factor of -1 out on the bottom, and I'll get x minus 4 for that one. I'll take another factor of -1 out, and I'll get x minus 3 here. And where I took the factor of -1, is I took it from here, right? So I divided this by -1, and I divided that by -1. That comes out and switches the signs, right? As long as I do it to both, I can take that factor out, right? I can take out that common factor. I always can, as long as I'm ensuring where that comes from. Well, here, the two negatives, right? This is all multiplication now. The two negatives become positive, and I'm going to have x minus 3 over x plus 3, and I'm going to have x minus 4 over x minus 3. And I know the two negative 3's will simplify with each other. And then I'll get my final solution here, and I'll get x plus 3 over x minus 4, and x cannot equal 3 and 4, right? So that's as simplified as it can be. Some common errors to watch out for. So if I have x plus 1 over x, we don't do this because that's not allowed. That's wrong, right? We don't do this. That's incorrect. Because what we actually have is x over x plus 1 over x. What we really have is 1 plus 1 over x, right? But if you did it this way, what you'd have is 2, right? So think about let's actually, you know what? I'm going to stop here, and I'm just going to go back and do common errors as its own video, just so that we're really clear and sure what's going on. So these are the skills. So we did the skills check. I'm going to go back, and I'll just start the common errors fresh. All right, math fans, have a great day.